really opens up a wide world of possibilities and profit. Should the device work as intended, it really faces no competition, so it could really shape its own market for months and potentially years to come. And should the device prove effective and all that, it could be sold to medical practices directly to the patient.
So for the budget analysis, as mentioned, we wanted to investigate a wide variety of magnets to use in the device, so we bought variety packs. We've got variety packs of the circular magnets and the bar magnets. We're going to use them. We're just going to test which ones work best together, which ones are safe based on a lot of the data that we collected on the different thicknesses of lips, based on things like that. And these actually tie into the design being adjustable, as the physician will use the circular magnets when fitting a patient for comfort and effectiveness. We got our mouth guards. We got 4, 1 for each group member, plus the test patient. And then we've got our safe silicone. It was $31 for 2 pounds, which brings us to $65.45. However, projects are unpredictable, and there's no telling what we could run into. Maybe none of the magnets work, we need to order more. Maybe we find magnets that work really well, and we'd like to order more of those specifically. So we've set an incidental budget of 35% of the total cost. It's another $22.90. But overall, we're still projecting at less than 1/3 of the $300 allotment.
So some of the tests that we want to do to make sure the device is, as I've been saying, up to standard, is of course we need to make sure the device is safe. We can't continue if the device is not safe. From there, we'll go into our comfort test. Is the device comfortable, of course? If there is any issues with that, that needs to be addressed immediately. The usability will be following that, where the device and how well it actually performs over long periods of time. And from there, the effectiveness, and of course how the device would be effective in the problem area. So the first test we want to do for safety is, of course, confirm there's no choking hazard within this, which is a big issue and scare within an oral device. And of course, for a choking hazard to occur, the device has to be small enough to enter the esophagus. So within dimensional analysis, we'll be able to confirm if the device is too large to enter into the esophagus and causing issues with that. That is also the purpose of the flap, to make sure there's no extra small parts that could fall into the mouth. From there, we'll go into test 2, which will involve one member of the test group wearing the device and going through a short sleep cycle under supervision to make sure there's no scares or issues even close to what we consider unsafe. After the device is confirmed safe, we'll make sure it's comfortable. To do that, we will give a prototype to our 4 test members, our 3 group members here, plus our test member, and have them wear it for about 3 nights, including any daily activities they go through. From there, we want to make sure the device had no issues with it. It was easy to use during the day if it didn't impede on any daily activities. And of course, any suggestions they would have for the device itself.
For the usability, we just really want to record any failures, because you have one time that device falls into your mouth and scares you. You might not ever want to wear it again. So we are going to use it for 3 consecutive nights, record any failures that may occur, like repositioning, detachment, discomfort, or sleep prevention. And the usability test here is also going to say, I've worn this for 3 nights. Is the material, is the device still performing up to standards? Am I noticing any wear and tear already? Things like that. The effectiveness. So here, the force analysis with ANSYS comes into play. We're going to generate data on how much pressure is actually applied to the philtrum. We're going to model it with 4 layers. You've got the epidermis, subcutaneous tissue, the orbicularis oris muscle, and the mucosa. They're all going to have a layer within a 3D rectangle on ANSYS, and each layer will have its own properties and characteristics that are true to what they would be within the software. The boundaries of the model will be tested by applying a normal force. This force we're going to get using the Gilbert model for magnetic fields between 2 magnets with non-uniform fields. And once we've chosen our magnets out of our variety packs, we're going to move forward with that so that we can have accurate numbers and that we're not running 50 force analysis when we could run 10. And this is just to ensure the magnets that we chose are applying appropriate force to the area, and it's not going to be too much. For our conclusion, design 1 utilizes pressure, utilizes silicone best overall. So we want to move forward with that one. It's going to be cost effective in its prototype phase and also when considering maintenance and upkeep. Clean it, keep it safe. The silicone has a very long shelf life. So if any kind of silicone damage happens, go back to your physician. He still has the silicone from where he sealed the plastic pocket, the silicone pocket. He can help you out there. But because projects are a revolving door and never static, we have found something else that we would like to present to you now. We want to add in when it comes time to the CDR, just another layer. We'd like to use a silicone gel in between the wound and the device just to assist with the healing and just to keep it moisturized under there and to not, if you're removing the device, have any pulling against the lip that would be uncomfortable or any unnecessary wound opening when you remove. That's something we've considered recently, and I think that our incidentals budget will assist in the cost of the gel. So we request permission in moving forward to actually build the prototype of Design 1 and to submit an application to the IRB for human testing.
This project is supported by Mercer University, so we would like to thank them and the professors, Dr. O'Brien, Dr. Vo, Dr. Hill, and Dr. Thomas for assisting us in any questions that we may have had. And we would also like to thank Dr. Yellen. Without his input, we really would have no idea on any designs or anything like that. So his input has really helped us and guided us in where we are right now. Are there any questions?
Can you throw up your two designs again, please?
Although I believe they're on two different slides.
Yeah, they're on two different slides.
So,
I drew the bar magnet on the right sticking out so you would actually be able to see it instead of it just being like another layer. So it would be actually molded to the mouth guard and not just sticking
and
out.
how's it going to be molded?
With the aluminum oxide.
Yeah, you can bend it and grind it into shape.
With an aluminum oxide
And they'll be
grinding wheel
thin enough-
that won't damage the properties.
They'll be thin enough to where you should be able to bend them. I think the thickest one is like 5 millimeters, so you should be able to bend it and mold it pretty easily.
To secure it actually to the mouth guard, that's where we'll be using the silicone as well. Possibly even like grind out a little area in the mouth guard to kind of allow it to recede into it a little bit. And of course that's where it would be used to kind of, the silicone would be wrapped around it as well to secure the little more.
What am I looking at on the left?
It's a side view of it with the flap extending all the way down.
Because we designed the flap, of course, was there to make sure there wasn't two different parts of the device causing that front part to possibly be a choking hazard. So this part of it would actually flip
Yeah,
under the lip and kind of continue and almost wrap from inside the teeth around the lip to the front.
Yeah.
So it almost makes like a U shape.
Oh, I was confused too.
Oh, I'm
I
sorry.
just didn't know how to draw
Yeah,
it.
so
with
if
being
you
able to
kind of
see
look at
it
it like this is the front of the mouth guard.
Yeah, that goes in your mouth.
Yes,
Yeah.
and then you have, this is the part of the flap that hangs down and will wrap
Around
around the
the lip.
vermilion.
Yeah.
And then this is the pocket that will contain the circular magnets that will go on the Philtrum, where they will be able to create that magnetic field with the magnet that's on the front of the mouth guard.
So you've got a magnet embedded inside the mouth guard, is that correct?
Yes, sir. Along with the circular magnets in the pocket.
Are you assured that they're going to be attracted? You know, light poles tend to repel, so how are you going to make sure that these things...
That's where the physician comes into play, and that's why we said the pocket's going to remain open. It's not going to be something that we wanted to send out already done. The physician's going to, the bar magnet's going to be the same across the board. The physician is going to test the circular magnets, going to hold it up, and make sure that the pole, it's, you know, the correct way, flip it one side versus the other side, so that the poles are attracted and not repelling. Once they've done that, they're going to make sure that it's strong enough to go through the flesh and create the magnetic field. And when they find the appropriate one, then they will put it into the pocket and seal it so that it can't fall out and become a choking hazard.
Why didn't you just go with the metal plate on one side or the other, so that you wouldn't have to worry about clarity of your magnet.
Also something we've considered, because we need to have magnets that are small enough to fit in the flap, the pocket, we don't know if, we're thinking we're actually going to need 2 opposing magnets to create a strong enough field to actually go through that flesh. We don't know if a metal will have strong enough properties.
So it'd have to be a really thin, moldable, or pliable piece of metal in order for it to be strong enough.
You've done no testing at this point. You haven't pulled in any magnets or anything like that?
We want to order the magnets, we found them. And moving forward, we plan to order them with permission tomorrow. Let's see.
What?
18.
Yeah.
Okay, go back to your other design. That was the winning design, correct?
The
No,
previous
the
one
mag
was.
ones.
Yeah, I mean, this one is
The
the
yes, sir.
winner, and
Yeah.
what am I looking at there?
So the best way to kind of describe this is for 3 different pieces where you have a piece of metal here, and then you have 2 retention clips, where you place the piece of metal, which is of course wrapped in silicone, over the top of the lip, and then you use these clips to go around the lip to actually hold them in place. The most similar thing I can kind of think of is a hanger that has like the trouser clips on it, where you have to like kind of push them down. Those kind of metal clips is kind of the thought process behind how we would do this.
I'd love to have one of those on my lip.
Exactly. That's why you can see that in comfort it got a 4.
But these are the 2 designs that Dr. Yellen liked the most out of everything that we kind of bounced off of him. So we just went forward with these 2 designs.
Okay. Do you need to have a flap on your winning design?
No, we don't need it. The flap came from safety concerns. Because if you're sleeping and you have just the circular magnet,
They could
you know,
fall off.
could
and
fall. You could
choke.
potentially go in your mouth. It could, it's just,
The flap will not be wider than the mouth, therefore it'd
Yeah.
be easy for it to fall in, especially if someone sleeps with a like a thicker pillow, and it kind of causes you to sleep with an angle on your head. It could cause during restless sleep to knock off in your
pop the
mouth,
magnet off.
We
It
didn't want
becomes a
to-
choking hazard.
or even fall sideways and then cause it as well.
Okay.
It was either that or do a nose ring where it kind of clipped to the nose ring.
I like
But then we ran against comfort again.
The pockets that
Mhm.
you're talking about,
Mhm.
can you draw on the board what the mouthpiece is going to look like in the pockets and orientation and all that stuff?
Okay. So the pocket is going to be on the flap, not on the mouth guard. So if you have a side view of the mouth guard, and you've got your bar magnet, which has been attached all the way around, your flap here is going to come down, and when it's applied, it'll form a U.
Yeah. And the
So
flap
you've
will-
got it here, and it's only going to be just thick enough to house these circular magnets.
So the circular magnets are going to be on the outside.
Yes.
They're inside a pocket.
On the
Right.
outside.
If you-
Outside the body.
Mhm.
Yeah, so the way we're going to create the pocket here is to,
But
This-
that's the wrong design.
No, this is for
This
the
is the
flap
actual
actually itself.
flap.
That's the
Yeah, this is
flap.
the flap.
We wanted that in our project implementation, actually, how we're going to build that as well.
so we've made a 3D mold of the dimensions, poured silicone into it, so there you have your flap. In order to actually create the pocket, we're going to take here in the dash lines a metal plate, sit it on top of the finished silicone flap, brush layers and layers and layers of silicone over the plate,
To make a
let that cure, remove the plate,
and
Yeah.
then make a little pouch.
So is the dentist going to be doing this fabrication, or this would all be done?
This would be
This
done
would all
pre.
be
The
done.
only
All be-
thing the physician will be doing is, of
Is
course,
closing
making
the
sure that the mouth guard fits, of course, using just boiling water. It was one of those mouth guards that you just kind of put in boiling water, have it sit in the mouth, kind of suck on it for a second, it seals in the mouth. And then from there, you just basically grab your magnets that you want, depending on the size, and put them in and kind of test them first to make sure that comfort's not too little or too much for the patient. From there, once that in, they just kind of pour the silicone into the top and kind of seal it off so those magnets can't shift within the pocket. So the only thing that the actual doctor
Physician
would
does
do,
is test the magnet, seal the pocket.
And you're going to get the strength or the, what's going to be the determining factor of the amount of pressure that he wants to apply?
so of course any pressure really helps with the scar healing, but of course it comes down to more the comfort of the patient, where we're kind of doing research to see if there's any issues with too much pressure, but of course it all came down to there's not much research actually on the top of the lip, so we started looking at the webbed area right here between the thumb and the pointer finger, and because it has a very similar histology to it, and it's used in Western medicine and pressure points, and they kind of came down to the aspect is if it's too much pressure to bear, that's when there's an issue really, and even after that point they're like it just kind of comes down to when it starts hurting you. And even if you actually pinch your upper lip with a flat pressure instead of a point pressure, your lip can kind of take a lot of pressure.
Mostly what we found was that ischemia was not a result of constant applied pressure. It was more a result of trauma, repetitive trauma.
You had done some pressure testing, right, or force testing? Was it force testing or?
It was force testing of a design that ended up actually not even making it into our presentation. It was a design that wasn't actually going to implement the same way that these did.
Okay, can you give me some idea of PSI that's going to be applied?
The closest thing that I've been able to find to something like that is the Gilbert model, which I have. Okay, so the Gilbert model. It is the force exerted on a point in between two magnetic fields that are non-uniform. So because we're going to have a bar magnet and a circular magnet, they're not like two identical bars or two identical cylinders. That's what we're going to have to use. It takes, I have it in here. It takes the area, surface area, the magnetizing field, the permeability of the space, and the distance away from the two magnets that you're going to be testing at. So this is really going to come into play with the ANSYS. How the thickness of the lip that we're using, which we've got a lot of data, we're going to take an average, and then we're going to take out any outliers, but then also do the thickest lip and the thinnest lip, so that on the thinnest lip, the strongest magnet can't cause too much force.
What PSI are you shooting?
I have the equation.
Yes.
I'm assuming it's going to be really tiny.
Really small.
Guess right now, it's fact.
Probably in the dynes, honestly. So.
I want it to be how many pounds per square inch are you going to do?
Once we choose a magnet?
We don't have that video right now.
Pinch your lips with your thumb and your fingers. I mean, how much PSI are you doing?
Half
Half square point.
3 pounds. 1.5 pounds. Per half square inch. 3.
We really don't have a definite